In this video, we'll continue our discussion of properties of the cross product. So in the last video, we stated that U cross V was orthogonal to U and V. So another way to think about this is that U cross V are perpendicular to the plane determined by U and V. So if you take a look at this picture here, we have U cross V, and it creates this plane, right? U and V live in a plane together. U cross V is orthogonal to both of those, the whole plane. We can create this right-handed system from this, and that's what they're talking about over there. The important part I need you to get into your head is that U cross V gives me an orthogonal vector that's orthogonal to both. We're going to use it quite a bit. So here's the deal, is we either have a vector, if I think about 3 space, right? Think about this picture here. U cross V either goes up or it goes down, right? It's kind of hard to picture the 3 dimensions, but it would be going straight down there. There is a way to determine if the U cross V is above or below. Place your palm on the right hand of U so that it closes towards V. Your thumb, when extended, will point you in the direction of UV. This is a very difficult thing to explain through a video on an iPad screen. So I put a link there in your notes. You can click that, and it takes you to somebody talking. You can see their hands and a board, and it makes much more sense than what I can do through an iPad. And I'm not going to recreate the wheel. The wheel's already made. The video looks fine. I'm not going to record myself on a wall like they do. Okay, check that video out. It will help with that right-hand rule. Does U cross V go up or does it go down? Okay, so find a non-zero unit vector which is orthogonal to both V and W. So we're going to try to figure out a vector. So if I'm looking for a vector that is orthogonal to 2 different vectors, I just find the cross product. V cross W, right? And they just say find a unit vector. Right? So I could do V cross W or W cross V, doesn't matter. So this is I, J, K, and then we fill in V, 1, 1, 1, and then W is -2, -3, 5. And now we use our cross product method. So I cover up the first row and the first column, and I get 1, 1, -3, 5, I, minus, right? Then we cover up the first row and the second column, and we get 1, -2, 1, 5, J. And then the last one, we have plus 1, -2, 1, -3, K. All right? Following this now, we multiply our diagonals, or multiply the diagonals and subtract them. So this is 5 minus -3, I, minus 5 minus -2, be careful with these minus negatives, J, and then plus -3 minus -2, K. So we have 8I minus 7J, and then that's going to be a minus K. We could also, so there's one vector that is orthogonal, or we could say -8I plus 7J plus K. We could just change the signs of each one. Both are going to be orthogonal. So this is V cross W or W cross V. Either one is orthogonal. One just points in one direction and one points in the other direction. Right? So that is how you find an orthogonal vector. It's just the cross product. All right, I'm going to run you through some algebra here to come up with a new formula. So recall that top one we discussed, and then this is just the angle between 2 vectors, but solved for the dot product. All right, so let's start with a cross product magnitude squared, and this is going to lead into a formula. So trust me on this. So this is that first rule. This is just A cross B dotted with A cross B. Now this is the part I'm going to need you to trust me. If not, the video is going to be very long. This is lots of algebra. If you'd like to try, please try, and you can send it to me. I'll help you get through it, but it is a mess. What we end up getting is A1 squared plus A2 squared plus A3 squared. Remember, those are just the components of vector A times b1 squared plus b2 squared plus b3 squared minus a1 b1 plus a2 b2 plus a3 b3, all that squared. So if you'd like to try that algebra, please do. It is pretty tough, but I believe all of you guys can do it. Okay, this part. So this thing here, if you notice, this is vector A magnitude squared. I want you to think about if A is A1, A2, A3, and remember that just means A dotted with A, that's what that would give me. Same thing here. Minus, okay, and then what's inside there is actually just A dotted with B. Take a moment, make sure you agree with that. That's in here. All right, that ended up being there, that ended up being there. Okay, so notice now, we can replace, using this rule, the dot product. So I'm going to write A magnitude squared, B magnitude squared, minus, okay, I replace A dot B with that formula. Let me fix that arrow over V. It looks like some weird, probably drunk snake or something. Okay, so there we go. I replaced the formula. Now notice that they both, oh, and I used a V and W using the rule up there. It should be an A and a B. So we have the magnitude A squared, magnitude B, nothing changes here, minus, and then I'm just going to distribute the square. Cosine squared theta. Notice that they both have the magnitudes in common, so I'm going to factor them out. So it's 1 minus cosine squared. Hopefully there is a bell ringing, right? Because that 1 minus cosine squared is a sine squared. So I'm going to rewrite my whole problem because I'm where I need to be. A cross B squared is equal to A magnitude squared, B magnitude squared, times, and this changes to sine squared theta. Notice everything is squared. So I'm just going to take the square root of both sides, which gives me the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times sine theta. That is a great formula there. That helps me find the magnitude of A cross B. All right, we're going to use this idea again. So recall, we used this a few sections ago. Recall a vector is equal to its magnitude times a direction. What I have right above is a magnitude. So we need to have A cross B. Another way we could write that is what we wrote there, the magnitude sine theta times some unit vector in the direction that we want to go. So this is a great formula if we know theta. Now, if I want A cross B and I don't know theta, A cross B is going to be my I, J, K determinant. If we know components, meaning each part of the vector. All right, X, Y, Z, or V1, V2, V3. Okay, a couple things. Let's ask a few questions to, there's a big thing we can grab here. Okay, so what if A cross B equals 0? So if A cross B equals 0, then magnitude of A times the magnitude of B sine theta is equal to 0. That is my cross product. So that means if that's true, then sine theta equals 0. Well, when sine theta equals 0, theta is either 0 or pi, which means that A is parallel to B. So if A, this is big here, if A cross B equals 0, then A is parallel to B. Let's put in words as parallel to B. All right. So there's sorry for my formula shoved in there. Let me just move that down. All right. So that's our big thing here. Due to our logic. So we have two things that are very important, right? If A dot B is 0, then A is orthogonal to B. So if I need to find orthogonal to determine, I would take the dot. If the dot is 0, then it's orthogonal. If I take the cross and I get 0, then they are parallel. It's another way to determine if two vectors are parallel.